Right. Let's look at question number 14, part A of the applied paper. So this is the vectors question. So A, B, C, D are four distinct points on OXY plane. Position vectors A and B are I plus 3j and 3i plus 9j. So OA vector is given, which is I plus 3j, and OB is also given 3i minus 3i plus 9j. And BC and BD is also given. BC is this, BD is that 6i minus 9j. First we have to show OAB are collinear. So we'll start with OB vector. Take the common term out. So you get what? 3 times I plus 3j. And I plus 3j is what? OA, no? OA vector. So OB is 3 times OA vector. So that means OB is parallel to OA. And O is a common point. No? O is a common point. Therefore, what is the conclusion? OA and B are collinear because OB and OA are parallel. O is a common point. So they have to be collinear. So that part is done. Then lines OC and AD meet at E for positive constants alpha. OE to OC ratio is alpha to 1. Show that E is equal to this given vector. Right. So we need to find OC then. Right. So OC we can find using what? BC. BC is given to us now. So we'll find OC. BC is equal to what? BO plus OC. Then OC is what? BC minus BO vector, which is same as BC plus OB vector. So then what is OC? BC is 2i minus 3j. OB is 3i plus 9j. So OC is 5i plus 6j. Right. We'll also find OD. We might need it. Yeah, we need it. Here we have something with AD. Right. So we'll find OD vector also quickly using BD vector. BD can be written as what? BO plus OD vector. So then OD vector is BD minus BO, which is same as BD plus OB vector. So 2i minus 3j. Oh no, that is BC. No, what is BD? 6i minus 9. 6i minus 9j plus OB. OB is 3i plus 9j. So OD is 9i, right? So we have OC and OD also now, right? Right. I will just graph it, but you don't need to graph this. Okay, I'm just graphing it to explain. You can do this whole question without doing any sort of graphing. You don't need a diagram actually, right? Oh. So D is 9, 9. A is I plus 3j, 1 comma 3. This is 3i plus 9j. Then C is what? 5 comma 6. Somewhere we'll mark here. That's C. 3. Let's say that 5 comma 6. Right. Then OC is this vector. Then AD is this vector. This is the point where they intersect E. Then we are given this ratio OE to OC is alpha to 1. Right. So alpha to 1 minus alpha then for OE to EC. Right. Then what are we supposed to show? OE vector is what we need to find. E vector, no, that is OE is equal to this. So then we'll use this ratio. OE divided by OC is alpha. So then OE vector is what? Alpha OC vector. No? So that is what? Alpha 5i plus 6j. So we get the result 5 alpha I plus 6 alpha j. Right. So that is the E vector that they ask us to find. Then what? For another positive constant, beta AE to AD is this ratio, beta to 1. Then we need to find another expression for E or OE in terms of beta, right? So then they have given this ratio, AE to AE to AD, which is beta to 1. So AE over AD is beta. So, right. So AE to ED would be that beta to 1 minus beta. Right. So now we need to find another way to write OE, which is E. So look at this triangle. So we can go O to A, then A to E. That creates OE, O to A to E then. So O to A first, then A to E. OA we know, AE we need to find. AE is what? Beta times AD using this ratio. Beta times AD vector. And then what is AD vector? That we need to find. We haven't found that yet. AD. AD can be written as AO plus OD. AD is AO plus OD. AO vector plus OD vector using the triangle law. Triangle addition of vectors. So now substitute. OA is what? 1I plus 3j plus beta. AO means minus OA. So then minus I minus 3j plus OD. OD is 9i. So then you can write OE as what? Group the terms. So this will give you what? I plus 3j plus 8i 8 beta I minus 3 beta j. So let's group them. So we get what? OE. OE vector as what? 1 plus 8 beta I plus 3 minus 3 beta j. So let's take this is 1, this is 2. Right. So we found that. So hence show that alpha and beta are equal to these values. Right. So these two are the same vector. Expression 1 and expression 2 gives you the same vector E or OE. So that means what? I components have to match. Phi alpha has to be equal to 1 plus 8 beta and j components have to match. 6 alpha has to be 3 minus 3 beta. So phi alpha equals 1 plus 8 beta using the I components. 1 plus 8 beta. Then from j components you get 6 alpha equals 3 minus 3 beta. Right. So solve 3 and 4 simultaneously. You get the answer for alpha and beta. So easiest way to do this is get rid of alpha by dividing 3 by 4. So 5 over 6 is 1 plus 8 beta over 3 minus 3 beta. So then 15 minus 15 beta equals 6 plus 48 beta. So then 63 beta is equal to 9, or beta equals 1 over 7. So then from 4 we get alpha. 6 alpha is equal to 3 minus 3 over 7. So 6 alpha is equal to 18 over 7. So alpha is equal to 3 over 7, right? Those are the two values we needed to show now. Let's check. Alpha is 3 over 7, beta is 1 over 7, right? Then we need to find OBD angle is equal to this, right? So then here we have to use cos, the cos inverse means dot product. So we need to find which angle. Let me draw that. OBD, this one. So my vertex is at B. So then the two vectors I have to consider are what? The two rays going from B. So I have to take dot product of what? BO dot BD. That gives you me this angle, OBD angle. You have to do BO dot BD. So the direction matters. You can't do OB into BD, okay? Because the vertex is where? B. The angle vertex is at B, so the two rays going away from it. So those are BO and BD, going away from it. So make sure you do BO dot BD, not OB dot BD, okay? So we'll do BO vector dot BD vector equals BO vector magnitude times BD vector magnitude into cos theta, which is what we want to find. So then BO is what? OB we know, no? OB is I plus 3j. So BO is minus I minus 3j dot BD, which is 6I minus 9j. 6I minus 9j. Then magnitude of BO is 1 squared plus 3 squared. 1 squared plus 3 squared, right? I minus 3, you know. See. No, sorry. That is OA. BO is what? Sorry. BO is 3I plus 9. So minus 3I minus 9. So 3 squared plus 9 squared here times 6 squared plus 9 squared here, square root cos theta. So let's take the dot product. I's multiply, you get minus 18. J's multiply, you get 81. Square root of 90 times square root of 170 into cos theta. 63 on this side. 90 we can simplify into 9 into 10, so 3 square root 10. 117 we can simplify into 9 into 13, so 3 square root 13 cos theta. So 9 square root 130 cos theta equals 63. So then cos theta is equal to 7 over root 130. Then the angle theta we needed to find is cos inverse 7 over root 130, right? Okay, main thing to notice here is this direction matters. BO dot BD. If you did OB dot BD, you would get a negative sign here. Okay, you won't get the correct answer. So make sure when you are finding this angle OBD, we are finding the angle at vertex B. No? So the two rays should come away from that point like this, BO and BD, right? So next, so that question is done. So next we'll look at the coplanar forces question.